our math class. Today we're going to solve and develop a problem that has been assigned to us by our math teacher. And we will show our skills that we've developed through this semester that are rate of change, derivatives, limits, and graphing. And this is our topic, population growth.
This is our problem. A lake is stocked with 500 fish and the population is increasing according to the logistic curve.
This is the equation we will use to solve our problem.
On the first question to our problem, we were required to graph the function. So we used an online grapher that told us exactly how to graph our function. So we plugged in our equation on an app called Grapher, and the graph automatically gave us this kind of exponential graph. On this case, the graph had an asymptote at the x-axis containing at x equals 0, and it also had an asymptote at the y-axis at y equals 0. So the line never touches this axis, it never touches x equals 0 or y equals 0, and the exponential graph goes a little bit like this. Our second question to our problem is to find the limiting size of the fish population. So what we're gonna do to solve this problem is to plug in different values of infinite x's, that is infinite time, to the equation. So we're gonna try three different values. The first value that we're gonna plug in for letter t, it's 100. The second value that we're gonna plug in is 10,000, and the third value that we're gonna plug in it's 1 million. So if we have our equation that it's 10,000 divided times 1 plus 90 exponential negative 100, that's the value that we chosen, divided times 5. First example, the answer that we get is 9,999.99. Now if we take our second value and plug it in for the number of t, we transform these 100 to 10,000. So if we plug it in on our example, we get we get 10,000 as the answer of our second problem. And for the third value, we do exactly the same, and we concluded that our answer is still 10,000. So that way we can conclude that the limiting size of the fish population is 10,000. No matter how many infinity of years passes on that lake, the population will be no more than 10,000.
Our third question is, what rate is the fish population changing at the end of 1 and 10 months? So what we have to do is to find the derivative of our equation and then plug in the number 1 and number 10, that is our amount of time. So we have our equation, and we pass this to the top. With a negative 1, and we apply it to this number, having a negative 10,000, and then we put this with the derivative of what's inside the parentheses, that is negative 19 25e. And here, subtract one number that is equal to negative 2 and pass it to the denominator of the equation. having our final answer. Now that we have our equation derivated, we will plug in our two values that are 1 and 10 months in the t's we have in the equation. So when we plug in the number 1, we will get a final answer of 113. That is according to 1 month. When we substitute our second value, that is 10 months, to our equation, we will get 4,032, that is equal to 10 months. Having our two final answers.
This is question number 4. After how many months the population increases most rapidly? Remember our first question, our graph looked like this. Here, we can observe that from between the months 0 and 16, our graph has a bigger slope, which means that between the months 0 and 16, the population is increasing most rapidly.
After these steps, we have solved the 4 problems of our equation. Thank you.